Hey everybody, let me write down a little bit of notation before we get into this interesting SMO junior problem. This notation, 6 vertical bar 30 means 6 divides 30. Another way of saying that is that 30 is a multiple of 6, in other words, this would imply, and it'd be a double arrow, I guess, that 30 is equal to 6 times 5. Right? Then we'll write it as 5 times 6, just to be explicit that it's a multiple of 6. I'll put a dot here. Okay, 5 times 6, okay. So this really reads 6 divides 30. Now that's useful notation. Now, what I'm going to do is just carry on here. I'm not going to read the problem to you, but it's there for you to read. We're going to give, A is a 4-digit number, so notice we have the 4 digits A, B, C, and D. And note right here that A, B, C, and D all have to be numbers between 0 and 9 inclusive. Now, A can't be 0, but all the digits A, B, C, and D are trapped between 0 and 9. That's the property of a decimal digit. Okay, so here's A, and we call it capital A right here. All right, now this right here represents a direct translation of all of this English here. It says let A be a 4-digit number when both the first digit and the third digit are increased by n. That's what happens right here. First digit increased by n, third digit increased by n, okay? And so on. The next part of it is the second and fourth digits are decreased by n. So that's represented right here. Okay, it's equal to n times the original number. Now let's go ahead and write down this would be equal to n times a, right? N times a. That's capital A, of course. Okay, so again, notice how the n just distributed all the way across. This is understood addition operation right here. So this piece right here is equal to n times a. And again, this very first line represents a direct translation of this English up here. Okay. Now the rest of this is just simplifying. In other words, notice that n gets multiplied by 1,000 here, minus n gets multiplied by 100, n gets multiplied by 10, and finally you just have minus n right here. And so that's how we get the 1,000, the minus 100, the 10, and the minus 1. When you simplify the arithmetic right here, you actually get 909n plus a is equal to na. When you subtract a from both sides, you get 909n is equal to n minus 1 times a. Okay, now something that comes in quite handy right here is notice that n minus 1 does not divide n. Okay, n minus 1. Okay, and let me put that in parens. Okay, n minus 1 does not, and so I'll put the vertical bar here with a slash, okay? N minus 1 does not divide n. Now that's very important here. N minus 1 and n are said to be coprime or relatively prime. Okay, that's super important right here because that means that since n minus 1 and n are relatively prime, that n minus 1 must divide 909. Okay, must divide. It can't divide. N minus 1 can have no factors in common with n. So it must, for this equality to hold, n minus 1 must divide 909. But notice that 909 is equal to, and I'll just write it right above here in the name of space, is equal to 9 times 101. Okay, 9 times 101. You'll notice that 101 is a prime number. So n minus 1 can't divide a prime number. That's the definition of a prime number, right? So n minus 1 must divide 9. Okay, n minus 1 must divide 9 since 909 is equal to 9 times 101, where 101 is a prime number. This piece right here, 101 is prime. Okay. It's not hard to verify that. You just check up to the square root of 101. So we get that. Okay, now, so that means that if n minus 1 has to divide 9, 9 has 3 divisors, namely 1, 3, and 9. Now, n minus 1 divides 9 would mean n is equal to 10, right? But notice that n equals 10 would be impossible. If you just take a look here, let me go up here. So right here in this case, we know that b is a number less than or equal to 9. And so if we subtracted 10 from that, we'd get a negative digit, which we can't. The digits have to be non-negative, right? Okay. Now, n minus 1 divides 1 implies that n is equal to 2. And we get something that appears to make sense right here because when you substitute n equals 2 in right here, 2 times 109 is 1,818. Okay, and so, and then if you put 2 minus 1 right here, you just get a, right? So in other words, substituting 2 here and here gives us 1818 equals to a, and that's legitimate. Now we do have to check 4 though. Okay, let's check 4. So n minus 1 divides 3 implies n is equal to 4. Okay, but notice that 2 is less than 4 right here. In other words, 2 would be less than 4. Okay, 4 being equal to n, right? But notice that that would be a problem in the original expression, right? Okay, this 2, well, let's just say this, we'll call this b, okay? We'll call this b because that's, okay. Okay. So this would be in the B position. We could also talk about D here if you wanted to. We'll use B, but we could also talk about D. But if you put a 2 right here, you get 2 minus 4 is a negative number, right? And you can't have a negative digit. So you see, we have to rule out this possibility right here and accept this possibility right here. Okay. So 1818 is the answer. Notice when you double 1818, you do get 3636. Right here, this is just impossible because of the fact it would lead to a negative digit right here, right? In other words, 2 minus 4 is negative 2. In the same thing, I guess, right here for D, if you wanted to use that as an example. So 8a is equal to 1818. We got to 3 separate cases. Only one of them actually worked. Thank you for viewing.